Hello and welcome to another installment of the geometry videos. This is section 2 and this is lines cut by a transversal. So our objectives today, we want to solve for angle measures when parallel lines are cut by a transversal. And we want to complete the steps to prove angle relationships given parallel lines cut by a transversal. Okay, when parallel lines are cut by a transversal, you have these two lines, and then if you draw in an extra line here, you get all these different angles. You get 8 angles, okay? And so we get a certain types of angles. We get what are called corresponding angles, which are angles that are in the same position, and we'll kind of talk about all this, but like 1 and 5 would be corresponding angles. They're in the top left corner of each intersection point. Okay, 2 and 6 would be corresponding angles. They're in the upper right. Okay, 3 and 7 would be corresponding angles, and then 4 and 8. Okay, alternate interior angles. These are angles that are on the inside of the two parallel lines, and they alternate between the transversal. So 4 and 5 would be alternate interior angles. 3 and 6 would be alternate interior angles. And then we have alternate exterior angles. So I've got angle 1 and angle 8. These are on the outside of the parallel lines, and they alternate between the transversal. So 1 and 8 would be there, and then 2 and 7 would also be there, would be alternate exterior angles. And then same side interior angles, so we'd be on the same side of the transversal, and we'd be on the interior in between the two parallel lines. Okay, so let's kind of talk about the relationships that we get between those two. And so the first one we have is the corresponding angles theorem. And so corresponding angles, when I'm talking about this, remember they're in the same position. So I'm going to write this. Corresponding angles are in the same position around same position at each intersection. Okay? So angles 1 and angle 5, angle 1 and angle 5 would be corresponding angles. Okay, angles 2 and angle 6, angle 2 and angle 6, angle 3 and angle 7. Okay, and the last one would be angle 4 and angle 8. So angle 4 and angle 8. Now what I know about these angles is that they are congruent. Okay, that's the big thing. Those angles are congruent. All right, and that's what a lot of these are going to be. Okay, so let's move on to the next one. Let's move on to the alternate interior angles theorem. And what this is, remember that these are in between. So in between the two parallel lines, in between the parallel lines, and alternate on either side of the transversal. Okay, so this right here is our transversal. Okay, so what we have is we have angle 3, okay, angle 3 and angle 6. So angle 3 and angle 6 would be alternate interior angles. They're on the inside of the two parallel lines, and they alternate between the on either side of the transversal. Okay, the other one that we would have is angle 4 and angle 5. So angle 4 and angle 5 are also alternate interior angles. Okay, and so the other thing we know about these is that they are congruent. All right, they have the same measure. All right, so then. Okay, let's take a look at over here. This is alternate exterior angles theorem. And it says if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. So these are on the outside, so outside of the parallel lines, and alternate on either side of the transversal. Okay, so we've got angle 2 is on the outside and angle 7. So angle 2 and angle 7 are alternate exterior angles. And then angle 1 and angle 8 are also alternate exterior angles. And these angles are congruent, okay? And that's what we've got. Okay, the other one are same side interior angles. And if the two parallel lines are, or if transversal intersects two parallel lines, then the resulting same side interior angles are supplementary. So those would be on the interior, okay, so they're inside, in between the parallel lines, and on the same side of the transversal. Okay, and so that would be something like angle 4 and angle 6, angle 4 and angle 6, and then the other ones would be angle 3 and angle 5. Okay, and what I know about these is that they are supplementary. They add up to 180 degrees. Okay, so that's what we've got for those. So that's, you know, something we did that in activity in class, so it should be pretty easy for us, but you should have this down just so you can take a look back at those. All right. So, you know, we have this little thing here where it says if they're corresponding alternate interior, alternate exterior, those are all congruent. But if we're same side interior, then they are supplementary. So here it says, you know, the parking space in a city lot was created by painting rows of parallel line segments, okay, and then painting a line that cuts through each of the parallel line segments, okay? And this would be where your car would park, okay, on the diagonal. And so it says, if the measure of angle 2 is 115 degrees, what's the measure of angle 1? So because I have two parallel lines cut by a transversal, these are same side interior angles, so I know that they are supplementary. So what I can do is I can set up an equation. And I can say that angle 1 plus angle 2 is equal to 180 degrees. Okay, so if angle 2, if this is 115 degrees, then I get angle 1 plus 115 degrees is equal to 180. All right, let me subtract 115 from both sides. All right, and so then angle 1 is just left with 65 degrees. Okay, and that's it. That's all we're trying to find. Okay, the next thing we want to look at is, you know, taking a look at this drawing and being able to figure out what the other angle measures are. So let's go ahead and zoom in on this. And the first thing I want to note is that I have these two parallel lines, and they're cut by two different transversals. Now, I know nothing about angles 1 through 8, so unfortunately, I can't make any claims about them. Even if I know what these other angles are, it tells me nothing about these angles. So angles, I'm going to write this, angles 1 through 8, we know nothing, okay? Kind of like in Game of Thrones, how Jon Snow knows nothing. You know nothing, Jon Snow. Okay, the other thing is that, you know, we do know that this angle right here is 100 degrees. So, based on what we know about intersecting lines, if this angle is 100 degrees, then I know that angle 11, that is the vertical angle across from it, is also 100 degrees. So I can come in here and I can draw in this statement here that these two angles are congruent. Okay, and I'll put that this is 100 degrees. All right. Now then, the other thing that I know is that this angle here and angle 14, these two angles are corresponding angles. Okay. So I know that these are congruent, okay? Now the other thing you can say is that these two angles were alternate interior angles and they're congruent, okay? It doesn't really matter, okay? I can say that this angle here is alternate exterior angles with angle 15 and that they're congruent. But then I could also say that these are vertical angles and that they're also congruent. So all these angles here are 100 degrees, okay? Now, that means that these two angles, okay, are congruent, okay, and that then because these two angles are alternate interior angles, that those are congruent, and then I can say that these are congruent because they're vertical angles. Okay, now the thing that we have to realize is that, you know, these two angles right here form a linear pair. So that means that they add up to 180 degrees. Okay, you could even talk about same side interior angles, and know that these two angles add up to 180 degrees, all right? So what I know is that, you know, if that one's 100, I know this is 80 degrees, and I know that this is 80 degrees, I know that this one's 80 degrees, and I know that this is 80 degrees. So if I am given two lines cut by a transversal, and I know one of the angle measures, then I can figure out all the other ones. Now, because I don't know any other angle measures here, I can't draw any conclusions, and that's all I can do, okay? So now let's go ahead and take a look at the next one, and it says, go ahead and find the measure of angle 3. Now, angle 3 is right here. Now, if I figured out what, you know, either this angle was or this angle was, I could figure out what angle 3 is. All right, and so, you know, the thing of it is that I want to be able to solve for x. So that's the first step. I got to solve for x in order to figure out what those angles are. And so what I know about these two angles is that they are alternate exterior angles, okay, and that they're congruent. So I'm going to come in here and draw those little marks, okay? So I can set up the equation because those two angles are congruent. I can write that x plus 10 is equal to 2x minus 30, okay? And I can solve this for x. I can subtract x on both sides, and I get that 10 is equal to x minus 30. I'm going to add 30 to both sides, add 30, and we get that 40 is equal to x. Okay, so now that I know what that angle is, I'm going to substitute it back in here. And so, you know, if I take that x is equal to 40 and I get 40 plus 10, I know that this angle measure right here is 50 degrees. Okay, so if this is 50 degrees, then I know that this is also congruent to angle 3. So we can then conclude that angle 3 is also equal to 50 degrees. Okay, so if this is 50 degrees, this is 50 degrees as well. Okay. All right, let's take a look at another one. And on this one, it's asking us to figure out what, you know, what the measure of angle 1 and angle 2 is, okay? Now, what I can figure out, the first thing that I know is that you're given that this is 75 degrees. All right, now I know that this angle is going to be congruent to that angle because they're vertical. I know that 75 degrees is going to be congruent to angle 2 because they are alternate interior. And then angle 4 and 75 degrees are congruent just because they are corresponding. So this is 75 degrees, this is 75 degrees, this is 75 degrees. Okay, so then I automatically know that angle 2, okay, is 75 degrees. Okay, I can come in here and just say that that's 75 degrees. Okay, but angle 1 is a little bit different. Angle 1 is going to be supplementary to 75 degrees. So I can set up an equation and say that angle 1 plus 75 is equal to 180. And if I subtract 75 from both sides, then I end up getting that angle 1 is equal to 105 degrees. Okay, so this is 105 degrees, all right? So you don't need to do a ton of work, but, you know, we've got to be able to set up equations and identify what's going on, okay? On this one, it says that angles 3 and 5, and let me just write this down, that angle 3 is 3x plus 4, so this is 3x plus 4, and then angle 5 is 2x plus 11, okay? Now, I know that these are same-side interior angles, okay, so these are same-side interior. Okay, and then what we want to do is we want to figure out what angle 5 is eventually, okay, and I'm going to set up an equation and solve this for x. And so because those are same side interior, I know that they are supplementary, so I can do 3x plus 4 plus 2x plus 11, add those together, and I get 180, okay? So if I do 3x plus 2x, combine like terms, it's going to give me 5x. And then I want to combine the other terms, which is going to be 4 and 11. That's going to give me a total of 15. So I've got 5x plus 15, and that's going to equal 180. So then if I subtract 15 from both sides, okay, then that's going to give me 5x is equal to 165. Okay, and if I divide all that by 5, okay, divide that by 5 and that by 5, that's going to let me know that x is equal to 33. Okay, now if I want to find what angle 5 is, okay, angle 5 had an expression value of 2x plus 11. So this is 2x plus 11. Now if I wanted to find what angle 5 was, I'm going to plug in 33 and for x, so I get 2 times 33, and then plus 11. So then I get 66 plus 11, which gives me a total of 77 degrees, okay? And so that's what I've got for that. Now, that's all I have for this part of the video. The next part will be a series of proofs that we will do, but, you know, just be able to solve these equations and set them up, just knowing the angle relationships, and we'll be good to go. All right, well, see you later. Bye.